Hi, welcome to my workshop. I'm Paul. Let's take a look at what's going on today.
I've had my PM-940 mill up and running for a while, so I thought I'd take this opportunity to check the accuracy in a number of areas, such as spindle runout, table squareness, etc. Let's take a look. The first thing I did was level the mill. I don't know if this was really necessary, but it was easy to do. I put a high precision level on the table, and as you can see, we're only off by one division. That's pretty good. Looking at the Y direction, let the level settle down. It is also quite level. I think this will be fine. The next thing I'm going to check is spindle runout. I can't check the inside of the spindle directly because I have the collet from my power drawbar in place, so I inserted a precision ground rod. This will measure the total runout of both the rod, the collet, and the spindle. As you can see, I have approximately 1 thou of runout. Next, I will check the x-axis travel. I'll place an indicator along the back of the table, which is a ground surface. I'll run it for about 24 inches. As you can see, I have a little under 2.5 thou of runout. Let's go back the other way and take a look again. Interesting, a lot less runout in this direction. I think this indicates that my gib needs to be adjusted. Now we'll check the table flatness in the x travel direction. I have the indicator on the top of the table and will move it about 24 inches. We seem to have a worst case of about 2 thou of runout. Let's go back the other direction and try again. We seem to have a high spot in the middle. I think the table is drooping as it reaches the end of its travel. Some gib adjustment might help this as well. Now for the Y direction. And back again. This looks pretty good, only a couple of tenths over the width of the table. That variation at the back might be due to table droop again, as it's close to the front of its travel. We'll take a look at the gibs.
The next step is to see how square X and Y are to each other. To do this, I have a precision granite square laying on the table. I'm going to line one edge with the X travel and then move the indicator over to see how Y looks. Let me move the camera so you can see the indicator. I've aligned one edge of the square with the X travel. Let's see what it looks like. It's within a couple of tenths along the length of the travel. That should be good enough for this test.
I've repositioned the indicator to show the runout along the Y direction. We're definitely seeing some runout here. It looks like we're seeing about 3 thou over the width of the table. We're also seeing this weird cyclical variation. I think that's due to a misaligned ball screw. When the ball nut reaches the front of its travel, it seems to torque the table slightly. Let's go back now. The cyclical variation goes away very quickly as the table moves toward the column. I'm going to have to look at that ball screw. We're now going to check the squareness of the column to the table in the Y direction. I have my square on the table vertically, and we're going to run the indicator up the edge. We're about 8 inches up and seeing about 6/10 the runout. At the top of the square at about 14 inches, we see about 2 thou runout. Since my work envelope in the Z direction is generally only about 4 inches or less, this should be perfectly fine for my needs. I could improve it by shimming the column to the base. I switched the square and the indicator around to test the squareness of the column to the table in the X direction. At about 8 inches, we're seeing about 5/10 of runout. At the top of the square at about 14 inches, we're seeing about 2 thou of runout. Again, this is probably adequate for my needs, as my Z work envelope is only about 4 inches or less. I can improve this by shimming the column. The last thing I'm going to check is a tram, or squareness of the head of the table. To do this, you use a tram gauge. Both indicators are 0 to the same point on the table, in this case a small magnet you see underneath the right-hand gauge. The gauge is then lowered onto the table. If both gauges read the same, it means you're in tram. If not, you have to adjust how the head is attached to the Z saddle to make it square. I'll adjust these to the 0 and get back to you. The gauges have been zeroed, and I'm now lowering them onto the table. You can see that they read almost identically. That means the table is in tram in the X direction. I'll now check the tram in the Y direction. I'll lower the gauges onto the table. You can see that we have about 3.5 thou of runout across 5 inches. This is not very good. This is quite a bit more than we saw when we checked the squareness of the column to the table. So that means that the head is not square to the column. We'll either have to shim between the head and the Z saddle, or shim the column to the base some more in order to compensate for this. I'll have to decide which way to go.
Well, there you have it. I think I've checked about everything I can. The worst case seems to be the head tram in the Y direction. Fortunately, this is pretty easy to fix. I can either put a shim behind the head, or I can shim the column to the base. It's time consuming, but not very difficult. I might be able to reduce some of the runout in other areas by adjusting my gibs, so I'll give that a try. The thing that concerns me the most, however, is the cyclical runout we see primarily on the Y-axis. This must have something to do with the ball screws. It's possible that I have a slightly bent or slightly misaligned ball screw, and I'll have to take a look at that. If anybody has any ideas, I'd sure like to know about it. In all, I'm reasonably happy with it, considering it's a Chinese mill. I think it's going to be accurate enough for most of what I do. My next project is going to be to take and put a servo on a dividing head and give myself a rotary axis. The only thing really left to do now is to replace the cheap micro switches I use for limit switches with something a little bit more appropriate. I did it quickly to get it running and it works just fine, but I think I could do better. If anybody has any ideas of what you're seeing here, I'd really appreciate knowing about it. I hope you enjoyed this video. I think I learned a lot, and I hope other people do. Thank you very much.